Hi, students of class 11. It's very good to see you. And I'm very glad that the problems given in the book assignment were successfully understood by many students. And I have seen some homework, and I have found that the students have really mastered the technique of solving those problems. But in today's lectures, I have more problems for our practice, and this time the problems are from the book examples, because some of the book examples look pretty complicated and maybe the students are going to find it hard to understand as compared to the assignment problems. So I have decided to basically explain these problems to you over here in this video, and then in the end of this lecture I will give you some similar problems with different values for you to solve at home and then share them with me. Okay, so here we go. We have a problem. I just pre-wrote the problem so that we can focus more and save some time. So I will seek your attention over here, and you can see that we have been given 4.6 grams of ethyl alcohol. Now, ethyl alcohol, you can call it ethanol. It works both ways, okay? This is the esterification reaction, if you could guess. 4.6 gram of ethanol, and then we have 6 gram of acetic acid. They are the reactants, okay? Now, you might have noticed that they have given us the quantity of the reactants in grams. See that? In grams. But the active masses are in moles per dm cube. Alright? So, in the first step, we have to convert these masses into moles. Before we do that, I will continue to tell you that they were kept at constant temperature until equilibrium was reached. And when the equilibrium was reached, then 2 grams of unused acid was left. Now this 2 grams of unused acid was determined with the help of titration against sodium hydroxide, as I have taught you once in the lecture of determination of equilibrium constant. So once again, you can see that the grams of the reactants are given, not the moles. So we basically have to convert all these given masses into moles first before we go to do our actual problem. So we are going to first mention here that now we are going to proceed towards solution. Okay, we are proceeding towards the solution to this problem. Now, before we go to solve it, we will first calculate the moles of the reactants. Okay, we can write here, we shall determine the moles of the reactants. Now you can see that, my dear friends, that we have the grams before the reaction and before the equilibrium was established or achieved, and the grams of the reactant once the equilibrium was established. So we will calculate moles in both cases. Okay, we can write like this: initial moles of ethyl alcohol or ethanol. So you should remember that the molecular weight of ethanol is 46. So we will divide 4.6, the given mass, by 46, the molar mass. You have learned in first chapter how to calculate the molar mass of any reactant or any substance. So you should first know the formula of ethyl alcohol, which is C2H5OH. And now you should know that the atomic weight of carbon is 12 and we have 2 atoms of carbon. Oxygen is 16 and we have 1 atom of oxygen. And hydrogen is 1 and we have 6 atoms of hydrogen. Now if you do the multiplication, so this is 24 and this is 16. So it's 40 plus 6 is going to be 46. So 46, which it is here, it is the molar mass of the ethyl alcohol. Good students, sharp students might have caught it when they saw in the book, but majority students like me, the average ones, will be wondering where did this 46 came from. So the initial moles of the ethanol, 46 upon 46 is 1 mole. So 4.6 upon 46 will be 0.1 mole. So if it was 46 upon 46, the answer would be 1. Now since this is 4.6, then it's going to be 0.1. This is the moles of alcohol, initial moles. Now we go for initial moles of acetic acid. For this, you must look for the given mass of acetic acid, 6 gram. Right? Now we divide it by 60. Now you might be thinking, oh, not now at least, that the way we found the molecular weight of ethyl alcohol, you can also find the molecular weight of the acetic acid. It's very simple. There are 2 atoms of carbon, all right, and there are 2 atoms of oxygen, and then there are 4 atoms of hydrogen. So we have this 24, this is 32, and this is 4. And if you add them all, the answer will definitely be 60. So 60 by 60, that was 1. Okay? But 6 by 60, that's going to be 0.1 mole. So, my friends, now you can realize that when in any problem, moles are not given. Like in the book assignment problems, we gave you 3 moles or 1 mole, or moles were given. The quantities were given in moles. So in the examination, if you see similar problems, but the quantities are in grams, better convert the grams into moles, then you start your reaction. Okay? Better convert them. But in this particular problem, we have 2 grams of acetic acid once equilibrium was achieved. So we can write that final moles of acid. Now again, it's 2 grams divided by 60 because 60 is the molar mass of acetic acid. And the answer will be 0.033 mole. How you do that? To divide 2 by 60, you must give a point and then 0, which it will make it 20. Still you have to give another 0, then it's going to be 200. And then 6 3s are 18, so 63s are, so this way you can reach this answer. Now, once this data is achieved, now we go for the reaction. Now the reaction, C2H5OH plus CH3COOH and double arrow CH3COO C2H5 and H2O. Many of you might be wondering that the assignment problems in this textbook are very, very easy. Why the example problems are so difficult? But it's not difficult. They are beginning with the grams. So grams must be converted into moles before you put them into the equation. Now, as you know, as we all know how we do it, we write the initial moles first. In this particular case, there's a 0.1 mole and 0.1 mole. And at this state, you know, it's nil. Now, what is the change? This is going to increase, this is going to decrease. So, change in reaction is minus x plus x plus x. Now, how do you write it? Equilibrium moles. How do you write it? 0.1 minus x, just add them. 0.1 minus x, just add them. 0 plus x, so it's going to be just x. This technique I have taught you in my previous lecture. Now, if you look at this line, this value, final moles of acid, at this stage we are being told that at equilibrium, this quantity for the acid is this much. Because 0.1 minus x also shows the quantity at equilibrium of acetic acid, and the data also gives us the quantity of acetic acid at equilibrium, which is 0.03. So if they are both presenting the similar quantity, we can put them equals to and find x, right? So I'm going to write here, I can write here from data we have, okay, you can see that 0.1 minus x represent the quantity of acid at equilibrium, okay? And our question also says that actual moles are 0.033 for acetic acid at equilibrium. So in this case, if you want to calculate x, how will you do that? X goes on that side and 0.033 come on this side. So you have 0.1 minus 0.033. And once you do this subtraction, the answer will be 0.067. To make you understand, I must tell you once again, consider this one, if this one was 100 and if it was 33, what is going to be 1 minus 33? It's 100 minus 33 is 67. Okay, 66.6 which is 67. So if it is 0.1 and 0.0003, it's going to be 0.067. All right. So in the next stage, my dear friends, we can write this again. Equilibrium moles 0.1 minus 0.067, because now we know the value of x. 0.1 minus 0.067, because now we know the value of x. This is 0.067. This is 0.067. I hope this change makes you clearly understand how to approach this problem. Now 0.1 minus 0.06. If 0.1 minus 0.033 was 0.067, what's going to be the opposite? It's going to be 0.033. So 0.033, 0.033, 0.067, 0.067. These are equilibrium moles. To make concentration, we will do one thing. What is that? Divide by V, divide by V, divide by V, and divide by V. And my dear students, you will put in the next step will be applying the law of mass action. You know, you have applied this law. What do you do at first? You have the value of Kc, in which the products, they go up as numerator and the reactants, they go down as denominator. Then you put these values, the V's cancel, and the quantities multiply and divide, and then you have the answer. So you should do this with this pattern. All right? So did you understand this one problem? And now, to give you some homework, I will give you a suggestion that repeat the same problem. You will solve this, okay? You have been solving this in the classroom because these lectures are exclusively made for you, so you understand what I'm trying to say here. Repeat same problem, but we will change the values. For example, instead of 4.6 gram of ethanol, let me give you 12.8 gram ethyl alcohol. Let's see how you find the moles and then you solve it, right? Let me give you 15 grams of acetic acid. Okay, now if I give you these two values and I give you the final moles here, you will just follow the similar pattern. So, but I want to give you some challenge. I want to challenge you a little bit. Let's see how you come up with this challenge. Okay, now I will change this problem and I will not tell you that the amount of acid left is this. I will tell you that at equilibrium, once the equilibrium was achieved, they were pre-mixed, they reacted, ester water was nil, but when the equilibrium was achieved, at that time, okay, at that time, just suppose you had 7 grams of ethyl acetate. Now find Kc. This problem I will give to my improving students. Even class 12 students should do this one and show me how do they approach it. Okay, because you will have the MCQ test of this chapter, so you must practice yourself here. So in this case, this step remains the same. You find the mole of alcohol, mole of acetic acid. You don't write the final moles of the acid. You write the moles, equilibrium moles of the ester. Keep in mind, this time you will divide 7.7 divided by the mass of the ester. How you find the mass? I will check in your homework. And once you find the mass, that will be the value which will replace X. This one division for ester will be X itself. So you don't have to find X like this. This step will be not required. In this step, we find X, right? Because we are given that at equilibrium, we have this much acid left. But if we are given esters, you don't have to do this step. Directly replace the X with that value and subtract that here as well. So I hope that you will do it and you will find it interesting to finding the Kc. All right, Kc must be 4, but because we have changed the data, so maybe our Kc is not 4. But the practice will really help us. All right, so we are done with this first problem. You can see the length of the problem is too much. You should do it, and then you can show me in your homework tonight. Thank you so much. I'll move towards my next problem. As I told you, I pre-wrote the problem so we can save the time here. This problem, you can see alcohol is 9.2 gram, acid is 3.6 gram, ethyl acetate is 1.1 gram, and water is 9 gram. And they are mixed together, which means that at the initial stage, we have all the reactants. So we must first find the moles of everything. And then once we find the moles of everything, then we go for the main reaction. So we're going to write the solution. How are we going to solve it? All right, the solution here. We find the moles of everything. So you can say moles of ethyl alcohol. 46 is the mass, if you know. Moles of acetic acid. 60 is the molar mass, if you know. Of ester, ethyl acetate. 88 is the molar mass. And water, if you know, 18 is the molar mass. So we divide 9.2 gram alcohol, we divide by 46. We divide 3.6 gram acetic acid by 60, the molar mass of acetic acid. We divide 1.1 gram of ester by 88, the molar mass of ester. We divide 9 gram by 18, the molar mass of water. So this way, when we divide all them, we get 0.06 moles of the, 0.06 mole is for the acetic acid, and for the alcohol, it is 0.2 moles. For the ester, we get 0.0125 moles, and for the water, we get 0.5 moles. Now, these are the initial moles. These all moles are the initial moles. This problem is kind of different than other problems. Okay, now we are good to go towards writing our equation. Okay, now we can easily write the equation, which is CH3 COOH, the acid, C2H5OH, the alcohol, CH3 COO C2H5, the ester, H2O, water. Now, we have acid 0.06 in the 6 moles, in moles, alcohol 0.2 in moles, ester 0.0125 in moles, and water is 0.5 in moles. From this data, these are the initial moles. Now, what is change? To change, I want you to look which side has more quantity. You can see 0.015 or 0.5, 0.2. They are more in quantity. So what are the chances that there will be a decrease in the quantity of this and there will be an increase in the quantity of this? Let X be the quantity. Okay. Now just add them as you can add them. Okay. So what is the equilibrium moles? Just add them. 0.06 minus X, 0.2 minus X, 0.0125, this time plus X, 0.5 plus X. And to find equilibrium moles, we just divided by equilibrium concentration, we divide by V. These V's actually cancel in the end. So you can say they are the concentration. Now applying the law of mass action. Now this is a very lengthy problem and you might be thinking, but we should do it. We should not take any risk here. So how you apply the law? You add Kc is equal to your products, CH3 COO C2H5, all right, and then you have water, H2O, and then you have your reactants, CH3 COOH, and then you have C2H5OH. You put them the values here and the V's cancel. I will just skip the of the V cancelling step. Kc is given as 4, so 4 is equal to 0.0125 plus X, 0.5 plus X, and at the bottom you have 0.06 minus X, and you have 0.2 minus X. Upon V, you can write it and then cancel it. Now this will multiply with 4 on this side. Okay, so you will have 4, 0.06 minus X, 0.2 minus X. And on this side, you can proceed with multiplication. How multiply? With this and this, then this and that one. If you know from class metric how you do stepwise multiplication. I will leave it to you. Now 0.0125 into 0.5 and then you write the answer here. Then 0.0125 into X, that will be having X. So in this way you have 2 values in numbers and 2 with X. The value with the variable X can be added together very easily. Okay, and the numbers are added separately. Same is done here, and once it's done, 4 comes into multiplication. Here and here you will see there will be X square. There will be X square here, there will be 4X square here. So you put the terms into one side, the equation becomes 4X square, minus x square. So let's take one step out here and write here 3x square minus 1.5525x plus 0.04175. This will be the quadratic equation. This is A and B and C, and you guys are very familiar with. So this you must open a step, do it. Like multiply every number and go on. And you must practice this, okay? For multiple choice question, this can be solved very easily if the quantities are in whole numbers. So improvers, if you are thinking it's too long for a multiple choice question, I think you are taking the gamble. Don't take the gamble and try to do it, okay? Once we are done, I will give you the quantities in whole numbers so you can solve it in a better way. Solving this quadratic equation will give you the value of x. All right? You know, x is equal to minus b plus minus square root b squared minus 4ac upon 2a. Everybody knows this is our quadratic formula. We use it to solve the quadratic equation. And our equation is 3x squared minus 1.5525x and 0.04175 equals to 0. Now our A is equal to 3, B is equal to minus 1.5525, and C is equal to 0.04175. You put these values in the quadratic formula. The answer of x is basically, there are two answers. One is 0.49 moles, other is 0.029 moles. So I told you that this quantity must be less than the quantity given. You have 0.2 mole of alcohol, 0.06 mole of acetic acid. How are you going to get 0.4? No way. So this is not possible. You know, there's a plus minus here. So you take plus and the minus, as I taught you in the classroom. So this answer is exceeding the quantity of alcohol and acid, almost everything. Okay, so you go for this quantity. This is our actual correct. This is possible. Now, if you wanna, now this is not the quantity of any substance. It is the change. It is the X that changed. Okay, if you remember, my reference C2H5OH, ethyl alcohol. It was in our given data, it was 0.2 minus X. If you remember when we got the equilibrium. So now here we put the value of X 0.2 minus 0.029, and the difference is 0.171 moles per dm cube. This is the concentration. So you can add concentration of acetic acid. To do that, you have to go back to the equation 0.06 minus x. So it's going to be 0.06 minus x. So it's going to be what? 0.06 minus 0.29. And the answer will be 0.031 mole per dm. Ester and water you should do. All right. Now you can see that this quantity, if the values are in whole numbers, then it is no excuse. It's maybe the complicated pattern of solution can convince you that this problem cannot come in as a multiple choice question. So why should we worry about it? But I will recommend you that you should worry about it, because if the values here are in moles, in whole numbers, there should be no excuse. And if this comes in the examination, there could be 4 different questions that could be asked from you. Alcohol left, it can be one question giving 4 answers. So you don't want to miss 4 questions in a multiple choice question, especially if it has to decide your future, whether you're going to be a doctor or not. So don't gamble. All right, you will do the concentration of ester, CH3, COO, C2H5, and you will do the concentration of water, which is H2O. Remember, for them, it's going to be plus 0.0125 plus X, so just X 0.29, and 0.5 plus X. So if you're listening to me, my dear friends, improving students, this question, if it comes with the whole number moles, then it's going to be very easy to solve, and one problem with equation can ask you 4 questions. Would you like to gamble and miss out on 4 questions? I would not do that. All right. Now let's go for the challenge. Okay. Repeat same. Show me this one. Show me the repeat one as well. All right. So we had 9.2 grams of ethanol in the previous problem. I want to go for ethanol. The 46 is the atomic mass, molecular weight. So if you multiply 46 by 3, that's 40, 40, 40, 120, and then 18. This is 138. So I give you 138 grams of C2H5OH, just to make the answers as whole numbers. Okay. And I want to give you 120 grams of acetic acid. CH3 COOH is the mass of the given grams of the acetic acid. You will find out the moles of acetic acid here as well. All right. For the ester, whose atomic mass is 88, I want to give you 44 grams of ester. CH3 COO C2H5. All right. And for water, I can give you, let's say, 18 grams of water. This will make things easy for you. And Kc is 4. So all the improvers out there, beware. 3 mole, 2 mole, 0.5 mole, 1 mole. The data will make very easily, and you have to find out the concentration of every substance once the equilibrium is achieved. So this one I want to see from you. Okay. I hope it is clear. Any questions, you can just send me on WhatsApp, and I will be very happy to reply. Next question and last for today is a third example where we have a reaction A plus B is equal to 2C, and we have the given value. So I will just move quickly. A plus B, then double arrow 2C. Okay, basically if in this question, if we have A moles of A and B moles of B, then there will be 2x will be the amount of the C, because see, 1 mole of A, 1 mole of B gives you how much? 2 mole of C. So if this is A mole and this is B mole, it's going to be basically 2x. So these are the initial moles. We suppose equilibrium moles, we suppose it's going to be A minus X, B minus X, 2X. I'm very sorry, it's going to be nil in the initial stage. So it's just like the hydrogen iodide equilibrium, if you remember. Okay, I'm doing the book example, but with an entirely different approach, so you're not confused. Okay, I hope you get me. Right now we know the concentration. To write the concentration, you need A minus X upon V, and then B minus X upon V, and then 2X upon V. We will apply the law of mass action. mass action. Then Kc will be equal to, products go up, so it's going to be like this. And the reactants go down, it's going to be like this. It's because this is 2C, that's why. Now we can replace them with the values, okay, which is these, but I just missed one step. According to our textbook, the A minus X is 4 and B minus X is also 4. However, the 2X is given to us, okay, because the quantities is given. I missed the value of C. C is equal to 6 mole per dm cube. It was in the book, I missed to write it. So the A minus X is 4, B minus X is 4, and the 2X is 6. So if you know from the data here, we make a data here, A minus X is 4, B minus X is 4. This is the concentration at equilibrium. And the 2X is basically how much? 6. So we replace them here. It's going to be 6 upon V whole square. It's going to be 4 upon V into 4 upon V. So it's going to be 36 divided by 16. V square and V square cancel, and the answer will be 2.25. Now, my mistake is this. I should have written here instead of A minus X 4, B minus X 4. I missed it because I had it here. So it's understandable. So Kc value is 2.26. This way, in future problem, you can use this technique. All right? Much easy. You can use this technique while solving the future problems. Okay? Now, if 2x, now this is the first part, finding Kc. Second part is to find the moles of AB. Now, if the 2x was 6, as given in the question, what will be x? 6 upon 2, which means 3. So x is basically 3 moles. Okay? I hope you get me, right? Now, just as this problem, we will write here, initial concentration, okay? Initial concentration, all right? We can simply determine this one. At equilibrium, we have A at equilibrium is A minus X. That is equal to 4. But if X was 3, then A minus 3 is equal to 4. A is equal to 4 plus 3. So A is equal to 7. That's how you find the initial moles of A. Very much important. For B, you will follow the similar steps because the amount of B is same. So for B, it's B minus X is equal to 4, equilibrium, but the X was 3. So B will be equal to 4 plus 3. So many students will be thinking that why this 3? So 3 is like this. So the solving is more elaborate in the books. So I would like you to do the similar problem. I will ask you to repeat the same problem. Do this one and also repeat. This time you can take A as 4, but let B equal to 5. Do you mind? Let A be 4 and let B be 5. And let C be 7. Now this time what I have changed? I have changed the value of A and B. So A minus X will remain 4, B minus X will become 5. And the 2X will be 7. If 2X is 7, what is X? 3.5. So things can change. Please do this question for me. All right? This will also make me happy to see how you are engaging in solving problems and how your skills are getting stronger and stronger day by day. My dear friends, after this, we have two more examples in our textbook. The example number 4 and 5. They are very easy. 4 and 5. You can do them for me and also repeat them with different values. In those two problems, we are given the equilibrium concentration. There is no plus x minus x, nothing you have to do. It's just like a data, all right? You have the amount of the reactant individually given, products individually given, just divide them. Once you divide them, whatever the answer comes, compare with the given value of Kc. And if the answer is equal to Kc, you will say the reaction is at equilibrium. If you remember, if your answer is more than Kc, backward direction, less than Kc, forward direction. Okay? I hope you will solve these examples at home. And I'm not doing them because they are very straightforward. And they both belong to the same, the similar, basically, equation, which is the hydrogen iodide equilibrium. Okay? Let me make for you once again, if you're confused in this one, the example 4 and 5. They both have the same equation, just 2Hi. This is a reaction, H2 plus I2, and the Kc is given. Okay, and they give you the amount, quantity, equilibrium quantity of everything. Like they give hydrogen at equilibrium 0.5, they give iodine equilibrium 1.5, they give you this one equilibrium at 5. So how you find Kc? You put the reactants, the products on the top. Remember this? And then you put the values here. So you have the values of 0.5 upon V into 1.5 upon V, and they cancel. And then 5 squared, which is 25. And once you do the solution, the answer is 3 into 10 power minus 2. This is the ratio. Now in the problem, the Kc is given 1.310 power minus 2. Now 1.310 power minus 2, look at this, compare. Okay, the product upon reactant. The ratio is 310 power minus 2 and the Kc is 1.310 power minus 2. You tell me which one is bigger. Exactly, this is bigger. The ratio of product to the reactant is much more than the Kc. 1.3, 3.0. Okay. Now this, it means the products have gone more than the reactant, so it will reverse. It's going to be in a reverse direction. Very much important question. You should definitely solve it. It will shift in reverse. In the fifth problem, it's almost the same. Just this is 0.2, this is 1, this is 12, and the answer is 0.0. In the fifth problem, the ratio is equal to 0.0106, and the Kc that they gave for that problem is 0.0194. Now 0.019. Now you can again check this one, that once again you can compare them. Okay, Kc is bigger and the ratio is lesser. 19 is more than 10. So in that case, this guy is more, so it's going to be forward. Solve the fourth, fifth. Don't understand, tell me, I'll do it again for you. So this will completely finish all the problems in the assignment and example. 100% part 1 of 6th chapter is complete. part 1, 6th chapter. That's complete. You solve it, this one, and you show me. Once I understand that all the students have understood this part completely, then I will make a test paper and I will send you in the WhatsApp groups, and also that will also tell you in the WhatsApp groups that time and everything I'll explain. It will not be tomorrow. I'm sorry I didn't inform you properly. Tomorrow, in the next video tomorrow, I will discuss with you the test pattern, day and time and everything. Okay? You now focus on this problem. Thank you very much. Goodbye. Have a good time.